All right. So we have explicit and implicit equations. Explicit equations are equations that are solved for a specific variable. So for instance, like y equals 3x squared plus 7. There's one example. Implicit equations are equations not solved for a specific variable. So we could have like x squared plus y squared equals 12 or something like that. Okay. You having issues there? Okay. I don't know. Try getting on the Wi-Fi, try getting off the Wi-Fi. Yeah. It's probably the stupid rain. Okay, so here's the good news. Whether you remember if it's explicit or implicit, that really is kind of irrelevant. What matters is the terminology when you're told to solve for things, because here's where sometimes, you got to make sure you know what's being asked of you. So it does say write each equation explicitly in terms of y. Honestly, that word explicitly is not usually there. It usually would just say, like, write the equation in terms of y. Okay, in terms of y means y equals, like y all by itself equals something over there. It could have x's, it could have z's, it could have numbers, whatever, but you got to get y all by itself. Okay, so that's what it means. You're solving for y, basically. So it says, then indicate whether the equation is a function. So we were able to look at the vertical line test and figure that out from a picture, but we may not know what the picture looks like, so we'll talk about how we figure that out here in just a second. So on number 1, if I want it to be explicitly in terms of y, I'm going to solve for y. So the first thing I would do is subtract x from both sides. So it's going to give me negative 4y equals 20 minus x. So then I want to divide both sides by negative 4. Here's what I don't want you to do. Okay, so don't do this because I'm going to undo it. I don't want you to go, all right, I'm going to divide them both by negative 4 like this. Okay, don't do that like all over 4 because that's where some weird things start to happen over there. Instead, you're going to be good boys and girls and show your work. If you're going to divide this by negative 4, you divide each term by negative 4. Like so. So that'll end me with y equals negative 5, and then a negative x over a negative 4 would be a positive 1/4 x. And I've solved for y. Okay. So here it is, written explicitly in terms of y. And then I have to decide whether or not it's a function. Okay, so there's ways algebraically to do that, but sometimes you're going to look at stuff and you're going to know what it graphs. If I was to graph that thing, what would it be? A line. It's just going to graph a line. You agree with that? Just like y equals mx plus b, except the mx is over here. So it's going to graph a line. All lines are functions unless they're vertical lines. That's definitely not a vertical or horizontal line. So is this a function? Yes, it is a function. Okay. All right, so let's look at number 3. And we are going to solve for y without making up math. That's the most important part here. No making up math. So I want you to look at number 3, and I want you to think without speaking about what, if I'm trying to get y by itself, what the first thing is that you would do. Just think about what you would do first. Okay, would I move the 1 first? Yes or no? No. Would I move the x first? That would make the most sense, right? So this is going to give me then y plus 1 squared equals 3 plus x. And you can make it x plus 3, but 3 plus x is fine too. Would it be legal for me to subtract 1 from both sides at this point? No, because it's inside those parentheses, right? So I have to undo the square. How do you undo a square? Square root. So listen very carefully. Unlike this, where when I divided every single term. When you square root the whole side. Like it's like an umbrella over the whole thing. I'm going to take the square root of both sides. It goes over the whole thing. Okay? So over here, because all I had was this squared, that square root takes care of that square because it's right there. So that just leaves me with y plus 1. And that equals, I don't put the square root over 3 and the square root over x. It doesn't work that way because there's addition there. That whole thing stays underneath there. But I'm missing something. Something that I have to put in there when I take the square root. Does anybody know what it is? Okay, so let me ask you this. If I told you that x squared was 25, and I said, what is x? What would x be? 5. Is that my only answer? Negative 5. Because see, I could take the square root of both sides, right? So I would get x equals the square root of 25, but it's plus or minus the square root of 25. So x would equal plus or minus 5, because both of those work. So here's I have this little bulletin board over here. Do you belong in math jail? These are all the things you can go to math jail for, and you can't afford the bail, I promise. So here's one right here. I introduced a square root and did not use plus or minus. If you introduce a square root in your solving, you have to put a plus or minus. You cannot forget that. Okay? A lot of times in geometry, it didn't matter because we were using lengths, so we didn't want the negative part, but you have to remember to put that in. So since we took the square root of both sides, this has to equal, since the square root stays there, plus or minus. And even if that was 9 plus x, like if I have the square root of 9 plus x, that does not equal 3 plus the square root of x. You can't break the square root up like that. You can if it's multiplication. You can't if it's addition and subtraction. Okay? So it has to stay like that. But now, can I move the 1? Now would it be legal for me to move the 1? Yes, now I can because it's just plain old subtraction. So I get y equals plus or minus the square root of 3 plus x, and then minus 1 on the outside of the square root. So don't get crazy sloppy with your square roots. That's got to be on the outside of it there. That is explicitly solved for y. You can't make it look any prettier. Sometimes they just look ugly. Okay? You good? Yeah. Okay. Sometimes all it takes is you get in the question halfway out and you're like, oh, got it. Okay, so my guess is you have no idea what this graphs. And that's okay. I don't expect you to at this point. So if we don't know what it graphs, we have to decide, but we still have to decide whether or not it's a function. So we look at, for every x on a function can have how many different y values? Just one. It can only have exactly one. So every x value can only have one y value, otherwise it's not going to work out, right? So you think about, all right, so like I could have said here, all right, like if I substitute in 4 on this one, 4 times 1/4 is 1 plus a negative 5. I'd only get one y value out, right? So let's pick a number here that would be an easy number. Let's pick negative 3. Oh, no, let's not pick negative 3. Let's pick negative 2, okay? So if I pick negative 2, 3 plus a negative 2 is a 1. So I would have the positive square root of 1 minus 1 and the negative square root of 1 minus 1. How many answers would I get? 2. So that one x value would give me 2 y values. So is it a function? No. That's how you decide. Okay? Does that make sense to you? If you don't know what it looks like, then that's what you're going to do with it. Okay? We good? All right. Let's look at number 5. I'm trying to get y by itself. So I would like for this square root that y is under to be positive. So I think I'm going to take this whole term, I just treat this as one term and just move it all over to the right. So I'll get x equals 8 plus the square root of y plus 1. And then I need to move the 8. So I'll subtract 8 from both sides, and I'll get x minus 8 equals the square root of y plus 1. Now, should that be plus or minus the square root of y plus 1? Did we introduce the square root, or was it already there? It was already there, so you just go with what they have. You don't try and get fancy here. How do you undo a square root? Square it. So now, to undo, because I'm focusing on this, I need to square both sides. Right? So when I do that, x minus 8 squared, I can just leave it x minus 8 squared. And then that's going to equal, when I square this, it'll just be y plus 1. Then, what would I do next? Subtract the 1. So I get x minus 8 squared minus 1 equals y. So does that become x minus 7 squared? No, you know better than that, no. And I don't even have to square the x minus 8. But let's say that we did. X minus 8 squared does not equal x squared plus 64. You don't get to just square both of them, right? That's not the way it works. When you do this, it is x minus 8 times x minus 8, which means you FOIL it, or you do the box, or you do whatever it is you learn to actually multiply them together and get a trinomial. You can go to math jail for that too. I thought that x plus 3 squared was x squared plus 9. If nothing else, you should know it's not that. I would rather you know it's not that and not be able to find it than think that that's what you're going to get. Okay? And there is a pattern for actually squaring this. It's one of your special cases. And it would be, you square the first one, so x squared. Then you multiply these two together, negative 8x, and double it, minus 16x. And then you square this one, plus 64. So there's a shortcut to that if you know your shortcuts. If not, you can still FOIL or box or whatever your thing is. It's fine. Okay, but we didn't even need to do it here. But since this is y equals, that would end up with an x squared in there, right? So what kind of equation is that? What is that equation called when there's an x squared in it? It starts with a q. What type of equation is it? It starts with a q. Quadratic. So if you graph a quadratic, what does it look like? What's it called? Well, it is a polynomial, so that's not a wrong answer. Do you know what it looks like? Like, can you draw it in the air? It looks like a U. Okay, it's called a parabola. Does that sound familiar? Okay, so if you know that it's a quadratic, so it's going to be a parabola somewhere in the universe. Is that a function? It is. Parabolas are functions, so the answer is yes. If you're not sure, then we can substitute in a number, right? I can do 10. 10 minus 8 is 2. 2 squared is 4. Minus 1 is 3. I only get one answer out, so I'm good. Okay, that's how I know if it's a function. Okay, we okay with that? All right. Yes, I have to write you a pass, though. Well, it's probably Friday. There you go. Okay, so we're going to skip number 6. Let's talk about function notation real quick. Explicit functions are frequently written using function notation. So if I have y equals 3x squared plus 7, to make that into function notation, that just becomes f of x equals 3x squared plus 7. That should be old news, old news about function notation. This is read as f of x. Okay, it's the value of the function f at x. So f of x just replaces y. That's all that's happening there. Okie dokie. We good on this? All right, let's move on to the next part then. We're going to look at evaluating functions. So if this is q of x, and I want q of negative 15, what does that mean that I'm supposed to do? If you look at this and this, the only difference is that x got replaced with negative 15. So that's what they're asking me to do. So here's the thing, and here's where some of you need to really pay attention, even when you're really good at this stuff. It's how you do your work and what you write down, okay? Your first step should be zero work. I don't care how easy it is. You just substitute it in. So Q of negative 15 equals the square root of 6 minus 2 times negative 15. Okay? First step is zero work, because you know what that shows? That shows that you understand how to evaluate a function. If you mess up on a number, okay, that shows you can't multiply. That's a totally different issue, right? So first step is zero work. You substitute it in. Even if it's super easy, 1 plus 2. Like 2 times 15 is not that big of a deal. Then I don't have to rewrite this left-hand side every time, but I do need equals here. So then this is going to be the square root of, I have 6. This is negative times a negative, so it's going to be a positive. What's 2 times 15? 30. So this is 6 plus 30. So that's the square root of 36. And what's the square root of 36? 6. So Q of negative 15 is 6. That's how you write your answer. It's not just a 6 that you box. Like, what is 6? Q of negative 15 is 6. Okay? So you've got to get real good at being able, somebody needs to be able to follow your work and know where numbers came from and all the good kind of stuff. Okay, we all good on that? All right, so let's look at number 13. I want f of 4. So f of 4 equals 5 times negative 3 to the 4th power. Now, can I start off by doing 5 times a negative 3? No. Aunt Sally says no. And I don't want you using a calculator. Remember I said I'm going to teach you how to use your brains the right way. Not the easy way, not the hard way. So I want you to think about, so the first thing I have to do is negative 3 to the 4th power. So the first thing I should think is, all right, if I take negative 3 to the 4th power, is it positive or negative? It's going to be positive, because if it's an even power, it would be positive. If it's an odd power, it would be negative. So I already know it's positive. I don't even care about the negative anymore, right? It's going to be a positive number. So then I want you to think about how you would take 3 to the 4th power without a calculator. Okay? And actually, I want you to just go ahead and find it. And then I'm going to talk to you about it a different way. Find 3 to the 4th power, because I want you to think about how you would do that. And then I'm going to show you a way and see if maybe that way is a little bit better for you. Okay? And you can jot stuff down. It's fine. You don't have to do it in your head. It's not always all about doing it in your head. Oh, I didn't ask what it was. I just said find it. Find it and keep it to yourself for a minute. Do we all agree at least that first of all I can drop the negative, and second of all it's 3 times 3 times 3 times 3, right? Even if you don't write that much down, like that's what you're actually doing. So this whole think smarter, not harder thing, right? You could do 3 times 3 is 9, 9 times 3 is 27, then multiply that by 3. That's fine. There's absolutely nothing wrong with that. But the more you practice the stuff I'm trying to get you to think about, the more you can think about something like that and group it differently. 3 times 3 is 9, and 9, so if I multiply those two together, what do I get? What's 9 times 9? 81, right? Oh, God. Well, you have to know your multiplication facts, first of all. And 9 times 9 is easier than 3 times 27. Would you agree with that? And that's going to work on a lot of other things. So if you think about how to regroup your numbers, but that doesn't come naturally if you aren't practicing it. So I'm telling you, practice them, try it, and then use a calculator to check yourself. I don't want you getting stuff wrong, but the more you do it, the more that calculator afterwards is going to match what you did, and everything becomes easier. Factoring, everything, I promise. But you have to know your multiplication facts. Get an app and practice if you don't know them. All right, so now I'm going to do 5 times 81. So let's talk about a different way to do this. Now, I could do 81 times 5, like you were taught in elementary school, whatever. That's not the way I do it, okay? And again, not about doing it in your head, because I usually do jot stuff down, because if I don't, I'll forget what my first number was. But I look at it this way. I know what 5 times 8 is, right? It's 40. So 5 times 80 is 400. And then 5 times 1 is 5, so this gives me 405. Do you see how easy that was? Being able to do things without a calculator doesn't mean scratch work all over the place and doing crazy hard long division and multiplication. No. It's about knowing how to manipulate your numbers to make things easier for you, okay? I just need a commitment from you to actually practice that stuff. Okay. All right. Let's look at 15. So this gives me I want f of 3y squared. So f of 3y squared. That means everywhere I see an x will be a 3y squared. So I'll get 3y squared cubed plus 3y squared squared. So here, because, now remember I told you, if you have x minus 8 squared, you don't just square them both and get x squared plus 64. It does not work that way. However, that's because there's addition and subtraction. There's no addition and subtraction here. So you actually are cubing each thing. So 3 cubed, what's 3 times 3 times 3? 27. And then I have y squared to the third power. What's your power to a power rule? That's your multiplying rule. Like if I had x squared times x cubed, that would give me x to the 5th. This means y squared 3 times, right? So that would actually give me y to the 6th. So your power to a power rule, you actually multiply. This will be y to the 6th power. Okay. Where did I get the 27? Oh, 3 cubed. 3 cubed is 27, and then y squared cubed is y to the 6th. Okay. And, oh, that looks like 2 times 7 now. Okay, there we go. Plus, and then 3 squared is 9, and y squared squared is y to the 4th. And that is f of 3y squared right there. Okay. What questions do you have? We good? Yes, sir. Oh, yes. There you go. Okay. So on 16, we have g of negative 5c. So g of negative 5c equals 3 times negative 5c minus 10 over negative 5c plus 5. I'm going to give you a second. I want you to simplify that. Think about what's legal and what's not legal, so you're not making stuff up. Okay, let's see what we got here. So I would get negative 15c minus 10 over 5c, I'm sorry, negative 5c plus 5. Let's talk about what you can't do here. That's what I see a lot of. You can't reduce these and reduce these because there's an addition and subtraction here. You can only cancel things out when stuff is straight up being multiplied. So this does not become 3c minus 2. Does not work that way. Doesn't mean that we can't simplify this, though. Do we have some GCFs we could factor out? I got a 5. And you know what? I think I'll use a negative 5 just because it's negative. It would really be okay if you did either one of them. But I'm going to take a negative 5 out of the numerator. So I get negative 5 times 3c plus 2 over, then this would be negative 5 times c minus 1. Do we agree with that? Now, because I have this big term up top and the big term down the bottom, and yeah, there's still addition and subtraction, but these are being multiplied here. Since it's being multiplied by this whole thing, these two can cancel out, and I get g of negative 5c equals 3c plus 2 over c minus 1. And that is my answer. Okay. What questions do you have? Careful with some illegal canceling. I don't get to just knock those out like that. Doesn't work that way. Okay. We all good so far? Okay. We're going to skip the next one so you can go on to the last slide once you're done. And let's look at this. So it says, using the graph to the left, find each function value. So here's what I want you to remember. This is f of 1. So what goes inside of here, what's inside of there, that is the x value. What you spit out, that is the y value. So if f of 1, I go here, here's f of 1, there's my x value. Well, when x is 1, y is 1, 2, 3, 4, 5, 6, 7, 8. Negative 9? Okay, negative 9. So you're just evaluating off a graph. You should only evaluate off a graph basically if you're told to, because otherwise sometimes you're just guessing. But I want you to go ahead and find f of negative 2, f of 5, f of 0. Make sure you can read the graph. I know some of the lines that are not the axes are darker. I don't know why, and I don't know how to fix that. So just make sure you're paying attention to which are the actual axis. Okay, so once you've got them, you can check with me, and then let me know if you have any questions.